Hello friends, welcome to Spartan's GRE. In this video, we'll be discussing one concept from time and distance chapter. Question is posted in one of our Spartan's GRE groups, WhatsApp groups. So before attempting this question, I would like to go in depth. I would like to explain all the models pertaining this topic. So this topic is about finding whenever two persons are walking in the same direction or walking in opposite direction, we are asked to find the meeting time and meeting place and nth number of meeting. Okay, and they give in so and so hours how many times they meet. These kind of questions will be asked in your exam. So this video is about the particular models. I'll be covering in detail. We'll be practicing around 9 to 10 questions. So let's get started with this video. Here the question says, two friends, Turbo and Black Shadow, simultaneously left two places A and B simultaneously respectively. Turbo left from A to B and Black Shadow left from B to A. However, every time that either of them arrives at his destination, immediately turns back to reach their starting position and then keeps on traveling in that manner between A and B. The question is, if the distance between A and B is 7 kilometers and the speed of Turbo and Black Shadow is 70 kilometers per hour and 20 kilometers per hour, how many times do they meet in the first 7 hours after they start? So this is the question. So before you solve this question, I would like to explain this concept in detail, taking few examples. So we'll come back to this question at the end of this video. Hopefully you yourself will be able to solve this question by the end of this video. So let's get started with the first question. Albert starts running from point P to point Q so we have 2 points, point P and point Q. So Albert starts here. He starts at 6 a.m. His speed is 40 kilometers per hour, and Bob starts running from the same point. Again, Bob runs from the same point. He starts running at 7 a.m. and his speed is 80 kilometers per hour. Now, this total distance between P and Q is 150 kilometers. Our first question is when they meet for the first time. So, and second question is when they overtake. Here there is a fundamental difference between meeting and overtake. If we have suppose a distance A and B is a distance. What is meeting? Meeting is nothing but meeting happens only when two bodies are moving in opposite directions. So one body starts from A, another body starts from B. At some point of time they meet, right? That is called meeting. Okay. So overtake is completely different. Overtaking when it happens is the body should move in the same direction. Suppose here again A is there, B is there, 2 points. One person X is starting like this and Y is starting this way. This is X and this is Y. He starts at 4 a.m. and this guy Y starts at 5 a.m. and speed of X is 10 kilometers per hour. Speed of Y is 30 kilometers per hour. In this case what happens is, the slower one, X, he started early, he runs some distance, right? So in 1 hour he travels 10 kilometers. This will be 10 kilometers distance. Now at this instance, the instance is 5 a.m. here. So at 5 a.m. X will be here and Y will be here. At this instance at 5 o'clock both starts running. So since Y is having greater speed, at some point of time he will definitely overtake him. This is called overtake. So you should not say meeting here in second case. Overtake happens, remember overtake happens when first condition is they should travel in same direction. This is our first condition. And second condition for overtake is the person who starts later, okay, later should have higher speed. Later should have higher speed. Only then he can overtake the slower person, right? So the person who starts early should be having lower speed, and person who starts later should be having a greater speed. So in that case overtakes happen. Now let's solve this question. So understanding this basic difference is very much important to solve the questions. You should know what is meeting, what is overtake. So you should observe what they are asking in your exam. If they are asking meeting, that is different. Overtake, you will get a different answer. What about interaction? Interaction will be meeting or overtake. So if they ask how many interactions happen, you have to find number of interactions, means it will be both meeting and overtaking, right? So our first question, so this is 160 kilometers and A started at 6 a.m. and then B starts at 7 a.m. So at 7 a.m. here it will be 7 a.m. for A. A will be here, and at 7 a.m. B will be here. So this distance will be how much? In 1 hour, A speed is 60 kilometers per hour, right? A speed is 40 kilometers per hour. That means in 1 hour, he traveled a distance of 40 kilometers, right? Now, what is meeting? As I told you, meeting should be in opposite directions. So A is moving this side and B is moving this side. So here they are running like this. Once A reaches this end point, he turns back and he will be coming this way, and now B will be going this way. Now meeting happens. You have to find that. So time is distance by speed. What is this distance? This distance will be initial distance. Initial distance or initial separation. Okay. Initial separation by relative speed. When we are talking about two bodies, you have to take the relative speed because both the bodies are in motion. So you have to take the relative speed. So here, what is the initial distance? The initial distance is very important. Meeting always happens when they are moving in opposite directions. Whenever two bodies are moving in opposite directions, the speed will be, relative speed will be plus. You can observe this practically as well. If you are moving in a train which is moving 10 kilometers and another train is moving opposite in 100 kilometers per hour, okay, you feel as if you are moving at a greater speed because the relative speed will be plus here. So in reality, you are moving with 10 kilometers, but when you are comparing with this second train, your motion will be of 110 kilometers per hour. So you feel as if your train is moving very fast. So whenever two bodies are moving opposite, the speed will be, relative speed will be plus. So here relative speed will be 40 plus 60, 40 plus 80. This is 120 kilometers per hour. We got this one, right? Now find the initial distance. This body is here. X is A is here right now and B is here, right? Now the initial distance will not be 40 here, okay? Initial distance will be, this has to travel how much here? This body has to travel this 40, this will be 120, right? So this body should be here to consider meeting. So to reach here, it has to travel how much? 120 kilometers plus. Now the bodies are opposite to each other. Now B is pointing towards A and A is also pointing towards B. What is this distance? This distance is 160 kilometers. And to reach this point, A has to travel 120 kilometers more. So your initial distance, IDS, initial distance will be 120 plus 160, which is 280 kilometers. So you got your IDS and you got your relative speed. That relative speed is 120. So it will be 280 by 120. It will be 47, 4 3s are 3, 2, 1 by 3. So after 2, 1 by 3 hours, they meet. Okay. So at what time they meet is from 7 o'clock. They meet after 2, 1 by 3 hours. 1 by 3 is 20 minutes. So they will meet at 9 hours, 20 minutes. So this will be your answer. So the meeting time is 9 hours, 20 minutes. Now let's solve overtaking scenario. Again, we have P here, we have Q here. Okay, 2 points. A at the 7 o'clock, A will be here 7 a.m. So A is moving this direction and now B will be starting from this direction. Now you see they are in same direction, right? So overtaking happens because the speed of Albert is only 40 kilometers per hour. Okay. And speed of the latter person is 80. Speed of the latter person is 80 kilometers per hour. Now this faster person will definitely overtake him. Now to find that, what is the initial separation here? Initial separation is this distance. What is this distance? This one will be 40. So IDS is 40. What about relative speed? Since they are moving in the same direction, the relative speed will be minus. So my relative speed is 80 minus 40, 40. So your answer will be, time will be 40 by 40. It will be 1 hour. 1 hour from when? 1 hour from 7 a.m. Here also 7 a.m. Here also it is 7 a.m. So the overtaking time is 8 a.m. So you got both the answers, right? So your first answer, meeting happens at 9:20 a.m. and overtaking happens at 8 a.m. I can show you this using a diagram. Okay, the diagram is very much important. So you observe properly how we are drawing the diagram. Okay, the diagram is nothing but instances diagram at a particular point of time where the body is lying. Okay, so we'll be mapping that diagram. That will be very much useful in the coming problems. From P to Q, the distance is 160 kilometers. For A to travel from P and reach Q, it takes how much time? Time for A will be 160 by speed of A is 40, so it takes 4 hours. Similarly, B takes 160 by 80, it takes 2 hours to reach Q from P, right? Now, if I draw the diagram like this is P, let this timeline diagram. First line will be P, second line be Q, right? I will use blue color pen for A, Albert. So Albert starts at 6 a.m. and he reaches P, Q at after 4 hours. That means if this is 6, somewhere it will be 10, right? 10 a.m. or p.m. let it be. Let a.m. okay, 10 a.m. This is a.m. it's given in question. So after 4 hours, it will be 10 a.m. Again after 4 hours, it will reach somewhere here. So this will be 2 p.m. Again 2 somewhere it will be 6 p.m. Again 6 it will be 10 p.m. 10 so here it will be 2 p.m. Now I will draw diagram for B. B starts at 7 a.m. If this is 7 a.m. he reaches Q at 9 a.m. because after 2 hours he reaches here. Somewhere it will be 9 here, right? This will be 9. If this is 6 and this, let it be 7, this one. Okay, 7 to 9, this goes like this, right? This goes like this. Again 9 means it will go here in 2 hours. It will be 11. So 11 will be, 10 is here, 11 will be here. So the diagram will be like this, 11. 11 to 12, 12 to 1 again. So this is 2 means, this will be 2 means, this will be 1. So it will come here, 1 o'clock. Again it will reach there at 3 p.m. Somewhere it will be 3 p.m. 3 to 5 again. So 5 will be somewhere here. So 5 p.m. 5 to 7. 7 will be somewhere here. 7 to 9. 9 will be somewhere here. And 9 to 11. 11 will be somewhere here. Like this, right? Now if you observe, we can see the intersection points, right? What are the intersection points? Here is one intersection point. Here is second one. Here is third, fourth, fifth, sixth, 7, 8. Here, looking at the intersection points, you can tell whether they are meeting or overtaking. How you can tell meeting is that arrow should be in opposite direction. As I told you, meeting always happens in opposite direction. Overtake always happens in same direction. Similarly here, B is moving downwards here. Here A is moving downwards, red color also moving downwards. That means when this meeting happened, the arrows are pointing same direction. That means this is not meeting, this is called overtake. So where it is happening, overtake. This overtake is obviously happening somewhere after 7. Here it is 7, the line goes like this, somewhere after 7 and before 9, right? So this point lies somewhere between 7 and 9, and when we solve, we got it. Our overtaking time is 8 o'clock, 8 a.m. and our meeting time is 9:20. Our first meeting, we are talking about first meeting and first overtake. So with the diagram, we are able to say, at least we are able to give a hint around which times it is going to happen. But when we calculated, we got the exact answer. Now let us see this one, this intersection. When this intersection happened, blue is coming downwards and red is going upwards, right? So that means this is called meeting, first meeting. So this first meeting happens, if you observe this dot, this is happening after 9, right? After 9 and before 10. So we got the answer 9:20. Again, if you take this one, it is coming down and this is going up. the both are meeting in opposite direction, though this is called second meeting. This is second meeting. And here again this goes up, this comes down. This is third meeting, and this one, this is coming down here, and this is also coming down. So this is second overtake, right? So second overtake is happening between 3 and 5, somewhere between 3 and 5. Okay, not exactly 3:30. You have to calculate it. So how to calculate second overtake, all these things I'll be telling in coming videos, right? Now let's move on to our next question. Second question says distance between 2 points A and B is 200 kilometers. So we have 2 points A and B. The distance between 2 points is 200 kilometers. A starts running from A to B at 6 a.m. and his speed is 60 kilometers per hour. And B starts from running again from A to B at 8 a.m. and his speed is 80 kilometers per hour. Then find when they meet for the first time and when they overtake for the first time. So let's solve our first question. Meeting, they are asking for the meeting. So for a meeting, as I told you, they should be in opposite directions. So here and here, A goes here, B this point. After 2 hours, right? So at 8 a.m. A will be here. So the distance here is, for 1 hour he is able to travel 60. So for 2 hours he will be traveling 120 kilometers, right? And he is pointing this direction, and this second person is pointing the same direction again. The whole distance is 200 kilometers. So this will be 80 kilometers, right? This distance is 80 kilometers. So for this person to face opposite to this second person, he has to go how much? The initial separation will be from here, he has to go this 80 kilometers. So once he goes to 80 kilometers, now he will be pointing this direction. So he has to travel 80 kilometers. So that will be considered as the initial gap. Plus, once he reaches this point, he turns back and faces the second person, B. So now A stands here and B stands here, and both are facing opposite to each other. The separation is 200. So now the total initial distance is 280 kilometers, right? So this is the idea's initial distance, and relative speed always it will be plus for meeting. So 60 plus 80, which is 140. So the time for the meeting time will be 280 by 140, which is 2 hours. 2 hours from when? 2 hours from 8 a.m. because we are considering from this instance, right? A starts at 6 a.m. and he reaches this point at 8 a.m. So at 8 a.m. both the trains are starting. Both the trains will be moving, right? So the meeting time will be 10 a.m. So your answer for first question is 10 a.m. Now let's solve for the second question. Again, now at 8 a.m. A will be here, this direction, and 8 a.m. B will be facing this direction. This distance you already got, this will be 120 kilometers. Since they both are pointing towards the same direction, we can find the overtaking time, because the speed of the latter person B is 80 kilometers and this is 60 kilometers. That means the person who starts late is having more speed. So definitely he will overtake A. So IDS initial distance will be 120 kilometers and relative speed will be minus. The minus will be 20. 80 minus 60, it is 20. So that will be 6 hours. So 6 hours from 8 a.m. it will be 8 a.m. plus 6 hours. So 4 hours means 12 and 2 p.m. So they overtake for the first time at 2 p.m. You can verify this using diagram also, but you won't get exact answer. I will tell you where exactly to use diagram, right? So let's move on to our next question. Now this third question is very important. Here in this question you will know the importance of diagram. So let's get started with this. Distance between A and B is 80 kilometers. So this is A and this is B. This is 80 kilometers. Albert running from A to B at 6 a.m. He starts at 6 a.m. and his speed is, so this is Albert. His speed is 40 kilometers per hour. And B, Bob starts at 7 a.m. and his speed is 20 kilometers per hour. Now, once they reach the position, this movement is to and fro. Now the question is when they meet for the first time. So meeting wise, no issues. Normally in exams, you'll be finding the meeting, but in case if they ask for overtake, then this question will be a troublesome one. Now, meeting happens in opposite direction. That means one person reaches here, and once he reaches, he turns back and he runs this direction, and the second person is this direction. So obviously meeting will happen. But when the overtaking will happen, suppose here A is Albert, he starts at 6 a.m. and 7 a.m. he will be here, right? Here A, Albert will be there, and this distance is 40 kilometers, and he will be running this direction. And here at 7 a.m., Bob will be here pointing towards this direction, and his speed is 20 kilometers per hour, right? And his speed is 40 kilometers per hour. In this scenario, when is overtaking will happen? Overtaking, in first run, B cannot overtake A. Why? Because A speed is more, right? 40 kilometers per hour. And second person who is starting late should be having more speed to catch up with the first person. But since he is having less speed, he is not supposed to overtake him in the first run at least. Okay, so when that happens is, so Albert goes here, he comes back, and again he comes back here, and he will be moving this direction. That time overtaking happens. So at first place, overtaking cannot happen because the person who starts late, he is having a less speed. So to solve this question, we have to use diagram. Right, let's solve a first question. When they meet for the first time, meeting should happen in opposite direction as I told. So at 7 a.m., Albert will be here, and at 7 a.m. Bob will be here. The distance here, it will be 40, right? It will be 40 kilometers. He is pointing this direction, he is towards this direction, and total length is how much? 80 kilometers, right? So this will be 40 kilometers. Now, initial distance in this case will be this pointer pointing this direction should become this direction. So it has to travel 40 kilometers. So this will be 40 plus once it reaches here, he turns back, right? He turns back, and here this whole distance, this will be 80 kilometers. So the initial separation should be 120 kilometers. Relative speed again, it is sum of 40 plus 20, it is 60. So that means they will meet after 2 hours. 2 hours from when? 2 hours from 7. So your first answer for meeting is 9 a.m. After 2 hours they will meet. So this is fine. No issues. No instance diagram is not needed. A timeline diagram is not needed for first question. But for second question, timeline diagram is compulsory. So let's get right. Time for A to reach the dead end. Like Albert takes from A to B, the distance is 80 kilometers and his speed is 40 kilometers per hour. So he takes 2 hours. A takes 2 hours to reach from here to here. Now time for B is 80 by his speed is 20. He takes 4 hours. Right? Now let's draw the diagram like this. This will be point, let this point be P and this will be Q. I'll use a blue color for A. A starts at 6 a.m. So this will be 6 a.m. and he reaches here in 2 hours. So this will be 8 a.m. Right? 6 and 8. Again he reaches at 10. Again at 12. At 2. At 4. At 6. At 8 and so on. Now I'll use red color for Bob. Bob starts at 7 a.m. He starts at 7 a.m. and he reaches in 4 hours. That means it will be 11. So it will be somewhere here. So he reaches this point at 11 a.m. and again after 4 it will be 3. Somewhere it will be here. Again it will be 7. Somewhere it will be, somewhere it will be here. This will be here, right? Now, where is the first overtaking? Here, if you see this point of intersection, A is going this direction, B is facing this direction. So this will be your meeting point. So this happens in between which time? In between 8 and 10, right? This point, if you see, this is more than 8 and less than 10. So somewhere between 8 and 9 it happens. So meeting point done. And if you take this one, this point, okay? If you take this point, this direction is again upwards, this is downwards, so opposite. So this also is a meeting point. So second meeting happens after 11 and before 12, somewhere in between 11 and 12. We are not worried about meeting, we are worried about overtaking. Take this point. This is going up and this is going up. Both are pointing the same direction. That means here is the first overtake. So here is the first overtake and we need to find the exact time when it is happening. Now, take this red line. This is Bob, right? This red point is Bob. So for this instance, Bob is starting at 11 a.m. He starts at 11 a.m. and his speed is 20 kilometers per hour, right? And this line, this red line. So we took this value. Now take the value of blue line, this one. Albert starts at 12 p.m., 12 noon, right? After 11, it becomes 12 noon. So at 12 noon. And his speed is 40 kilometers per hour. Now you see the overtaking condition is satisfied here. As I told you, overtaking, first one is they should be pointing to the same direction. Second one is the later person, the person who starts late should have more speed. Only then overtaking happens. Here you see Bob is starting at 11 a.m. His speed is 20 kilometers and Albert, he starts at 12 noon. That means after 1 hour of Bob he is starting. So his speed is 40. Now overtake will happen. So using this you can find the answer. Now see, what is the initial distance? So 11 o'clock Bob started and he goes and he travels by 11 he started here and by 12 he will be here. So here it is Bob. The gap will be 20 kilometers and at this point it will become 12 for A. Here Albert will be there. Albert will be pointing the same direction again. So at 12 B will be here and A will be here. The distance, initial distance will be 20. So IDS is 20 kilometers and the relative speed is 40 minus 20, which is 20. So it will be 1 hour. So 1 hour from when? 1 hour from 12 noon, right? You have to take the latest one from which instance we are calculating this. We have to take that. 11 Bob started and he goes, by 12 Bob will be here and by 12 A will be here at 12. So at 12 we are calculating this meeting time or overtaking time from 12. So it will be 1 hour from 12. So it will be 1 p.m. in the noon. So your answer will be 1 p.m. right? So let's move on to our next question. So our fourth question says the distance between 2 points X and Y is 60 kilometers, right? Let's see this. Yeah. It's 60 kilometers between X and Y. It is 60 kilometers. And Sam starts at 6 a.m. at a speed of 30 kilometers per hour towards Y. And Rock starts at 8 a.m. at a speed of 10 kilometers towards Y. Now we are asked to find, this is a to and fro journey. So that means once S reaches here, he turns back and comes back to X. Again he goes to Y. This repeats. So the question is when they meet for the first time and when they overtake for the first time. Here for when they meet for the first time, there is no issue at all. Directly we can answer it without using timeline diagram. Whereas to find the overtake in this question, we need to draw the timeline diagram. Why? Because the person who starts late, he is having less speed than the person who started early. So here, definitely for sure we can say that in the first round, there will not be overtaking, right? Overtaking can happen during a second round or third round and so on. But then during the first round, it won't happen. So to find the time in between the first overtake happens, we have to draw the instances diagram, the timeline diagram. So let's solve our first question, meeting time. So meeting time means at 8 a.m. by 2 hours, this S travels 60 kilometers, right? He started at 6 a.m. and by the time R starts his journey, it will be 2 hours. In 2 hours, S will be traveling 60 kilometers. So if this is X and this is Y, S started from here at 6 a.m. and by 8 a.m. he reaches here. So he now, once he reaches here, he will be turning back. He faces this direction, and R at 8 a.m. he is facing this direction. Now, what is the total distance between these two R and S when they are facing opposite to each other? The distance will be 60 kilometers, right? So IDS is 60 and the relative speed is how much? 30 plus 10, it will be 40. So this will be 3 by 2 hours, which is 1 by 2 hours. From what? From 8 a.m. So it will be 9:30 a.m. So you got your meeting time. Now let's solve our overtaking time. So for overtaking, you need to draw a diagram. Second question. Let this point be X and let this be Y. You can quickly draw this diagram, no issues at all. So I'll take blue for S. S starts at 6 a.m. So let it be 6 a.m. And this distance is 60 kilometers and his speed is 30. So he takes 2 hours to reach Y. So if this is 6, let it be 8. And for this one, R, he takes 6 hours, right, to reach bottom. So this is 8. So let this be 10. This will be 12. And this will be 2. Now, for R, he starts at 8 a.m. here and he reaches after 6 hours, right? 6 hours means it will be 2 o'clock. He reaches here at 2. So if you draw it, it will be like this. We got 3 intersection points here. So find which one is overtaking. So this is down, this is up. So this will be meeting point, your first meeting point. So this will be in between 8 and 10. You got it already, 9:30. So somewhere it will be here 9, right, in timeline. So this is 9:30. Your second meeting point, this is coming down and this is also coming down. So both directions, that means this is the overtaking. This is the first overtaking, right? So you need to consider this point. Now take this red line. It says 8 a.m. 8 a.m. For whom? It is for R. His speed is 10 kilometers per hour, right? And take this blue line. This blue line is starting at 10 a.m. and this is for S and his speed is 30 kilometers per hour. Now you see, the slower one is starting at 8 a.m. and the faster one is starting late, 2 hours late. So now overtaking condition is satisfied. Now you can find the answer. So the initial distance will be in 2 hours. R will travel how much? It will travel 20 kilometers. So it will be by 10 a.m. here R will be here and this distance will be 20 kilometers. And this at 10 a.m. S will be here pointing towards this direction, going towards this direction. So your IDS is 20. So it will be, time will be 20 by relative speed. Since they are going in same direction, relative speed will be 30 minus 10, which will be 20. That means 1 hour. 1 hour from where? 1 hour from 10 a.m. So your first overtaking time will be 11 a.m. You can verify that in the diagram itself. Here you see This point lies after 10 and before 12, somewhere in between 10 and 12. We got the answer, it is 11, right? Okay, so let's move on to our next question. Right, our next question says distance between two places A and B is 200 kilometers. If this is A and this B, the distance is 200 kilometers. Anthony starts from A, so A starts from here. Anthony starts from A towards B at a speed of, his speed is 60 kilometers per hour. Bob starts from B, so let this be B, at a speed of 40 kilometers per hour. He starts towards A. Then find their 13th meeting, when their 13th meeting happens and where their 13th meeting happens from B. So see this, when they meet for the 13th meeting happens, right? For 13th meeting, suppose when the first meeting will happen, if I want to ask you when they first meet, this is meeting, not overtaking, okay? When they first meet, so for meeting they should be in opposite directions. So here this is pointing here and this is pointing towards this one, they are opposite directions, fine. Now what is the, when they are opposite, what is the distance between them? It is 200 kilometers. That means the first meeting, the initial distance between them will be 200 kilometers. Agree? Right. So when they will meet, so time will be initial distance by relative speed is again 60 plus 40, it is 100. So after 2 hours they will meet. So somewhere in between they will meet. So let this point be this one. So if this is your first meeting point, they're meeting here. Now when they will meet for the second time, for that to happen, once A and B meet here, A has to go this direction till here and B has to travel till here. Now A faces here, it will be here, and B will be here. So for your second meeting, what happens is A has to travel this part and B has to travel this part. So this total distance will be 1D, correct? And again, once they travel this one, again the separation between them will be 1 more D, correct? So it will be 2D. But then whenever we are calculating initial distance, we have to calculate from the beginning of the time. So what is the beginning of the time? What I mean to say is, initially from we are suppose if you are calculating for the second meet, the initial distance for second meet will be, see here, first meeting happens here, right? They haven't actually moved. We are directly calculating the time for the second meet. That means still we are here only now, and B is here only. First meet happens somewhere here. For second meet, it has to travel this, and that is 1D, and again this gap will be 2D. So total it will be D plus, what is this D? For second meet, initial distance will be that initially they are here and here, right? So that D plus, once they meet, meeting happened once, right? During first meet, after first meet, they have to travel 2D, right? 2D into 1. So that will be your, so total distance will be 3D. So it will be 600 kilometers. This will be your initial distance. And speed will be again 100. So it will be 6 hours. So second meet will happen after 6 hours. For suppose if you want to calculate third meet, so instead of calculating like this manually, what you can do is, this is a formula, D plus 2D into number of meetings, n minus 1. So that will be D plus 2D into, this will be third, n will be 3. So 3 minus 1, 2. This will be 4D plus 5, 5D. So the initial distance will be 1000 kilometers. And then relative speed is 100. It will be 10 hours. So your third meet will happen after 10 hours. What about ninth meet? If you want to find the initial distance for ninth meeting, right? Still they haven't moved it, right? So A will be here and B will be here. So this distance is D. So we are finding the initial distance for ninth meeting. So that will be D plus 2D. What is this 2D? The 2D, I told you, once they meet for the first time, again they have to go back to their separate places. That will be 2D into 8. Here it will be 8 because they have to move for 8 times. To meet for the ninth time, they have to move 8 times. This 2D they have to move for 8 times. Example, you can take this second meet itself. For the second meet, initial distance A is here and B is here, so this distance is D. And for the since we are calculating initial distance for second meet, so we have to go to the meeting point. Once you reach the meeting point, A will go here and B will go here, and now this distance will be one more D, and again this separation will be one more D. So that will be D plus 2D into 1, because for second meet they have to travel this 2D only once, right? Similarly for ninth meet, this 2D will be 8 times. So this will be a formula. So initial distance for ninth meeting will be D plus 2D into 8. So this will be 16D plus 1D, 17D. So initial distance will be 17D, right? Now our question is, when they meet for the 13th time. So how will you calculate initial distance? Initial distance will be D plus 2D into 12. Because for 13th meet, they have to move 12 times from the first meeting. So this is how I told you how this 2D is derived and why we are putting one number less. So here it will be 24, total 25D. 25D, D is nothing but 200 kilometers, right? Yeah. So your ID is, yes, initial distance is 25 into 200 kilometers, and the relative speed is always positive plus, since they are moving in opposite directions, that will be 60 plus 40, it will be 100. So this will be 2, this will be 50 hours. That means the 13th meet happens after 50 hours, right? So our first question is done. So let's move on to our next question. Now our second question is where they will meet from B. That's what they're asking, right? Where they will meet from B. 13th meet happens from B. So here A and B meets after 50 hours for the 13th time. So in 50 hours, how much B will travel? So distance traveled by B in 50 hours will be 50 into its speed. Speed of B is 40 kilometers per hour, right? So this will be 40. So total you are getting 2000 kilometers. 2000 kilometers. If you take this timeline here, this is 200 kilometers, this is A and this is B. From B, suppose we are taking for B only, okay? This B in 50 hours, he travels 2000 kilometers. That means he travels one time, it will be 200, second time it will be 400, like that. 200 into X will give you 2000. So that means he will be after his 50th hour, after 50 hours, he will travel 2000 kilometers. That means in 50th hour, that means which in 13th meet, they will meet exactly at B. Understand? So where they meet from B is they exactly meet at B. So that will be your answer. Right. Our sixth question says distance between 2 points P and Q is 120 kilometers. A starts from P towards Q at a speed of 40 and B starts from Q towards P at a 60 kilometers per hour, and this is a to and fro journey. Then find how many meetings happens in 12 hours and at what time will they meet for the 41st time. This is your second question. Where they meet for the 41st time. This is your third question, right? So let's answer your first one. Distance between 2 points P and Q, this P and this Q, this is 120 kilometers. A starts from P and this travels towards Q at a speed of 40 kilometers per hour, and B starts from PQ and goes towards AP and its speed is 60 kilometers per hour, right? Now, how many meetings happen in 12 hours? So to solve this question, first I will explain you using timeline diagram. Okay, then we will see how to solve this even better. I will draw the timeline diagram here. This is P and if this is Q, for A to reach from P to Q, it takes 3 hours. So if I take blue color for P, so if it starts at 0, it reaches Q at 3 and this point will be 6, this will be 9, and this will be 12. I'll use red for B. So B starts at 0 again. It reaches P in 2 hours. So let this be 2, right? Again comes back at 4. So somewhere here it will be 4. Again it reaches here at 6. Again comes back and reaches here by 8. Goes here and reaches by 10. Comes back and here reaches by 12. See this? This is called saturation point. Exactly after 12 hours, A and B will reach their original positions. A started at 0 and by 12 hours it reaches P again, right? In the same time, B reaches Q. That means if both are running towards each other, okay? First meeting happens somewhere, then again A goes here, B goes here. A will reach B sooner because because this is a small distance and this is big distance. So again, while this to and fro is happening, at some point A and B reaches their original position at the same time. Understand? What I mean to say is, once they meet somewhere here, for A to reach here it will take less time, and for B to reach here it may take more time. It's not compulsory that they will reach at the same time after crossing each other, but at one point of time they will reach their original positions at the same time. That is called saturation time. That means after 12 hours they reach their original positions at the same time. So if you count their intersection points, here 1, this will be 2, and here 3, and here 4, and here 5. Total 5 intersection points are there, right? That means when we are counting number of meeting points from beginning to the saturation time, you're getting 5 here. So instead of solving this way, you're getting, when you draw the diagram, you are able to say that how many meetings happens in 12 hours, number of meeting happen is 5. But if the number is more here, if they're asking for what happens for after 36 hours or 42 hours, then will you be drawing the timeline diagram for so long hours? No, it's not possible. So just write the timeline diagram till the saturation point, and from there you can calculate it. So if I want to find the number of meetings in 46 hours, right? In 46 hours. If this is the question, normally this kind of question will not be given, because 46 hours means what you have to do, this 46 should be written in terms of 12, because for every 12 hours they meet 5 times, right? So remember, you cannot do like this, like in 12 hours they meet 5 times. So in 1 hour they meet 5 by 12 times. For 46 hours they meet 5 by 12 into 46. This kind of mistake you should not do, okay? So this is a blunder, so don't do this way. What you have to do is, in 12 hours, in 12 hours they meet 5 times. For 24 hours they meet 10 times. This is correct. Why? Because we are going in cycles, right? We are going in cycles. So 46 can be written as 12 into 3 plus 6. So there is a cycle of 3 times, right? So for every 12 hours they meet 5 times. So there are 3 such cycles. So 5 into 3, 15 times. So this is done. So for 36 hours they meet here. For 36 hours they meet 15 times. Till here it is fine. We need 6 more hours. In 6 hours how many times they meet? This you can tell only if you draw the diagram. That's why normally this will be a tough question, difficult question. So you will not be asked to find number of meetings in 46 hours. What they ask is whichever is doable without drawing diagram, only such questions will be asked. Even the question which I have shown, the GRE question which I have posted earlier, there also they are asking for 7 hours. That is also doable without diagram. So see here, for 60 hours you can find number of meetings only by drawing diagram. Here in 6 hours, 0 to 6, these 6 hours, how many meetings are there? 1, 2 and exactly on 6th hour one more meeting, 3. So here we are getting 3 meetings. So total number of meetings will be 18 meetings. So this will be your answer, right? But if you are doing in the wrong way, how much you are getting? 5 into 46 by 12. 5 into 46 by 12. That will be 9.1 times. But actual answer is 18 times. So it will be, your answer will be 18 times. Now I'll tell how to solve this question without using diagram. See this. You know, A takes 3 hours to go from P to Q and B takes 2 hours to go from Q to P, right? Now A takes 3 hours. So that means A takes 3 hours to go from here to here, 3 hours, from here to here 3 hours. That means A takes 6 hours to go and come back to this line, right? 6 hours, right? So this number, whatever numbers you are writing here, that will be multiples of 6, right? Because to go toward to and fro, it takes 6 hours. Again, it takes 12 hours now, because from here again 3 and here 3, it will be 12 hours and so on. For B, to go from here to here, it takes 2 hours, and to come back it takes 2 hours. That means here the numbers will be of 4 multiples, 4, 8, 12 and so on. So the number which is the LCM of, so for A to go to and fro it takes 6 hours, for B to go to and fro it takes 4 hours. That means first line will be multiples of 6, so it will be 6, 12 and so on, and second line will be 4, 8, 12 and so on. So your first saturation point happens at the LCM of 6 and 4. That means here you see the timeline value 12 here, and it is also 12 here. That means exactly after 12 hours they reach their original positions at the same time. You got it? Now in such scenario, once you are able to find the saturation hours, you can say number of meetings will be, if the sum of the speeds ratio. What is the speeds ratio here? It will be 40, 60. That is a 2:3 ratio, right? Speeds ratio is 2:3. Number of meetings will be 2 plus 3. So number of meetings will be 5. So there will be 5 meetings till 12 hours, right? Now let's move on to our next question. At what time will they meet for the 41st time? So, you know, for the 41st time, initial distance will be d plus 2d into 40. So this will be 81d. So your initial distance is 81 into total distance is 120 kilometers. So your initial distance, you got this, and the relative speed, this will be 60 plus 40, which is 100. So this get cancelled. So it will be 97.2 hours. So they first meet after 97.2 hours. Okay. So we got our 41st meeting happens after 97.2 hours. So this is one way of doing. Now let's do in second way. I'll tell you a second method. Now I told you the saturation point is 12 hours, right? After 12 hours, both A and B reaches their original positions at the same time. So we have to take this saturation time. So what happens is, in 12 hours, they meet 5 times, right? In 12 hours, they meet 5 times. Now, 5 times means if we do into 8, it will be 40 times. So to meet 40 times, they meet 40 times in how many hours? Into 8, if we do here, 96 hours. So 40 times they meet in 96 hours. But then we are asked to find 41st time, right? So to meet 40 times, it takes for them 96 hours. Now we need one more meeting. So if you take this line, right? If you take this line like this, P and Q, right? Here this is P and this is Q. Now exactly in 40th, once they meet for 40 times, that means exactly after 96 hours, what happens is A will be in its original position and B will be in its original position, right? That's what I told you, saturation hours. So After every 12 hours, A will be in its original position and B will be in its original position, and that too they reaches their original positions at the same time. So we can take one complete cycle as 12 hours. Now 96 means 8 complete cycles. Now 41st meeting will be the meeting which they do after this 40th. So what is the initial distance between them? So the initial distance is 120 kilometers. So the time will be distance by speed. Distance is 120. A relative speed. So relative speed will be 100. So this will be 1.2 hours. That means they take 96 hours till 40. So it will be 96 plus 1.2, which is 97.2 hours. We got the same answer, right? Now we'll solve our next question. Where will they meet for the 41st time? So when is already done. Now we will find where. So where means we already got time. They will meet after 97.2 hours, right? So if this is P and Q and A goes like this and B goes like this, the speeds are speed of A 40 and 60. Now distance traveled by B. If I take any one, I can take. If I take distance traveled by B in 97.2 hours, distance traveled by B will be 60 into 97.2 kilometers. So that will be 972 into 6, these many kilometers. And you know, total length is 120 kilometers. This total length is 120 kilometers. So how many times B has to move to cover 5832? So we divide it 5832 by 120. 5832. If you divide by 6, it will be more. So 5 more, 480. This will be 30103. We take 2 here, and this will be. So if I take this 8 times, it will be 960. So 2, 7, 72. So this will be, these kilometers can be written as 48 into 120 plus 72. That means B covers this 120 kilometers 48 times. So first round this will be 1, 2, 3, 4 and so on. This 48 is even number. So that means till 48 times it will be here, and then it goes 72 kilometers extra. So your answer will be 72 kilometers from B, or you can also say subtract 72 from here. It will be 8 and 4, 48. So it will be 148 kilometers from A. So anyway you can solve this, right? So you can either say 72 kilometers from B or 48 kilometers from A. Both are right. Now we'll solve our question number 3 using method 2 to avoid this long multiplication. You know, in 12 hours there will be 5 meetings, right? So 41 meetings, 41st meeting we are talking about. 41st can be written as, see, these 5 meetings will be taken as one set. So one set. So how many sets we can form out of 41? So I can form 41 can be written as 8 into 5 plus 1. That means 8 sets of 5 meetings we take as one particular set, right? 5 meetings will be one set. One set, I meant to say this P and this Q. By the end of 5 meetings, A will be in its original position. At the same time, B will be in its original position. Now 41st meeting means this particular set is repeated 8 times and we are going one step forward. That means 41st meeting will be equal to your first meeting. You can take it that way. So what is your first meeting? When your first meeting happens, what the time for the first meeting to meet for these two guys is 120 by relative speed 100. It will be 1.2, which is 6 by 5. 6 by 5. So 6 by 5 means this is the time, hours. Now if you want to calculate the distance, that means you want to calculate distance from A to the meeting point, the distance traveled by A in 6 by 5 hours. A speed is, A speed is 40 kilometers. So 40 into 6 by 5, and similarly from here it will be 60 into 6 by 5. So this will be 5 8s are 48 kilometers from A, and this will be 12 72 kilometers from B. This is the same answer we got here, right? So you follow the second method. Instead of using this division, you follow this one, right? So we are done with our 6th question as well. So let's move on to our next question. 7th one question. The distance between P and Q is 140 kilometers, right? So this is P and Q is 140 kilometers, and then A starts from P at a speed of 40 kilometers per hour, and B starts from Q at a speed of 30 kilometers per hour. This is the question, and this is a to and fro journey. Then find what time they will meet for the 86th time. So in method 1, what I will do is 86th time means the initial distance IDS will be D plus 2D into 85, right? So this will be 171D. That means 171 into distance is 140. So this is the initial distance. The relative speed will be 40 plus 30, that will be 70. So their meeting time TM will be 171 into 140 by 70, which is 2 times 243, 342 hours. That means after 342 hours, they will be meeting for the 86th time. So now I'll be doing in method 2. Now let's solve the same question in method 2. Let's imagine this line. Here let this be P and this is Q. You need not actually draw the diagram. See, normally how much time it will take for A to reach from P to Q? It takes how much time? 140 by 40. So this will be 7 by 2 hours. So for A to reach from P to Q, so suppose this is A, to reach from P to Q, I will use blue color. Yeah. So reach from P to Q, it takes 7 by 2 hours. Again, from here to here, to go back to P, it takes 7 by 2 into 2, right? Because here it is 7 by 2 and this also will be 7 by 2. So total from here to here, it takes 7 hours. Into 2 and 2 get cancelled. So it takes 7 hours. Again, next here, coming here and going here, now it takes 14 hours, right? Because this 7 by 2 and 7 by 2, we have 4 into 7 by 2. 4 into 7 by 2 will be 14 hours. So if you take this P timeline, for A, it will be for one complete round trip to going to Q and coming back to P, it goes in multiples of 7. That means here it will be 7, this will be 14, this will be next trip, next it will be 21 and so on. So P is multiple of 7. It goes like this: 7, 14, 21 and so on. Similarly for Q starts here, right? I'll take a different color. Q starts here, and for Q to go from for B to go from Q to P, it takes 140 by 30, which is 14 by 3 hours. So from here to here it takes 14 by 3, and from again here to here it will be one more 14 by 3, so it will be 28 by 3. That means, so next again going here, coming back here, it will be 56 by 3. Again going back and coming here, it will be, so it's actually going in multiples of 28. Agree? Correct, right? Because for one trip from here to here 14 by 3, so going to P and coming back to Q, it takes 28 by 3. Next it will be 56 by 3, and next it will be again, this will be 84 by 3 and so on. So this P timeline is a multiple of 7 and this Q timeline will be multiple of 28. If you take the LCM of 7 and 28, you will get 28. That means, see here, you can see one thing, one observation here. For P, it will be 7, 14, 21, 28, 35 and so on. For Q, this will be 28 by 3, 56 by 3 and 84 by 3. If you see this 84 by 3, this is nothing but 28, right? So here the common point is 28. That means exactly after 28 hours, A will reach P and B will reach Q at the same time. So here the cycle is 28. So for every 28 hours, there will be how many meetings? For every 28 hours, there will be exactly 7 meetings, right? 7 meetings. Now, we want how many meetings? We want 86 meetings, right? The question is 86th meeting. So this I can multiply with 12, it will be 84 meetings. 84 meetings plus 2, and this if you multiply with 12, you will get 280 plus 56, 6, 3 and 3, 336 hours here. Plus here 2 meetings. So now you find how much time it will take for them to meet second meeting, to have second meeting. So second meeting, you know, the distance, initial distance will be d plus 2d, that's it. So it will be 3d, 3 into 140 by relative speed is 70. So 2 the 6 hours. That means for second meeting it will take 6 hours. So add that 6 here, you will get 342 hours. This is what you got in your earlier method 1 also, right? So any method you can follow. The thing is, just you have to know that the cycle is 28 hours. For every 28 hours, there will be 7 meetings. They asked for the 86th meeting. That means we will calculate in terms of cycles. 86 can be written as 84 meetings plus 2 meetings. 84 meetings means it is a multiple of 7. That means 2 complete round trips, right? So now let's move on to our next question. Where will they meet for the 86th time? So where will they meet for the 86th time? Or second question, where for 86th time? Right? Now, method 1 again. You know, they meet for the 86th time after how much time? Time is equal to 342 hours. Suppose if I take B, in 342 hours, B travels a distance of 342 into how much speed? For B it is 30 kilometers per hour. I'm just calculating for B. So it will be this many kilometers. 10260 kilometers. So when they meet for the 86th time, B would have traveled total of 10260 kilometers. But our total distance itself is how much? It is 140 kilometers. 140 kilometers. So this 10260 should be written in multiples of 140. So you will write as 140, 10260. If you divide this, you will get here 7. It will be 980. So this will be 460. And if you still divide it, it can be 420, right? 3 times. It will be 420. So remainder will be 40. That means this 120 can be written as 140 into 73 plus 40. This 73 means B is here. Okay, this is point Q, this is point P, this is A, this is B. Till 86th meeting, the B would have traveled this many kilometers. That means 140 into 73 times. So first time it goes here, second time it comes back, third time it goes here. So 1, 3, 5, every odd number gets counted here. So 140 into 73 means after covering this distance, B will be at this point. Now it has to move 40 kilometers. So it will move 40 kilometers here. That's it. So this will be your meeting point. 86th meeting point will take place where? Where means it is 40 kilometers from A or from P, or you can also say 100 kilometers from Q. That's it. So this will be your answer for this question. Now let's solve in our second way to avoid this huge calculation, this long division, right? So our second method would be, now we'll solve the same question using method 2. We want to find the 86th meeting. When, not when, where. We also found 86th meeting will be equal to our second meeting, right? Second meeting, done. Now where this second meeting will happen? This 86th meeting is equal to second meeting. So when this second meeting happens, to find this, when this second meeting happens, initial distance will be d plus 2d, that is 3d. 3d means 3 into 140, and relative speed is 70. So divided by 70, it will be 2, that means 6 hours. So after 6 hours they meet for the second time. So in these 6 hours you can either find the distance covered by A in 6 hours or distance covered by B in 6 hours. If I take B, in 6 hours it will travel a distance of 180 kilometers. But then we have total 140 kilometers here, right? This is A and this is B. In 6 hours it travels 180 kilometers. That means it travels from here to here 140 and then one more 40 here. So 140 plus 40. So now this is the meeting point. What is this? This will be 40 kilometers from A or 100 kilometers from B or from Q. Sorry, this is P, this is Q. The same answer we got using our method 1, right? So this is how you solve the question. These are actually difficult questions, but then we are able to solve them easily with the concept. Now let's move on to our 8th question. Now coming back to our main question, and exclusively for this question I have made this entire 1.5 hour video, right? So here the question is, this is a GRE question that was posted in one of our Spartans GRE WhatsApp groups. So the question says, two friends Turbo and Black Shadow simultaneously leave two places A and B. So left from A for B and Black Shadow. Okay, right. This is A and this is B. Turbo leaves from here and Black Shadow leaves from here. The speed of A is, distance between A and B is 7 kilometers and the speed of Turbo is 70 kilometers per hour and speed of Black Shadow is 20 kilometers per hour. The question is how many times they meet in first 7 hours after they start, right? So how many times they meet in first 7 hours? Now if you draw the timeline, you are actually not required to draw the timeline, but still see this. I am not drawing the timeline here. For suppose if I am taking this as A and this point as B, this line as B, for T to travel from A to B, how much time it takes? 7 kilometers by 70 kilometers per hour into hours, if you take, it will be 6 minutes. So for here, for T to come from here to here, it takes 6 minutes. And again, to go back to A, it takes 12 minutes. That means total from starting from here to here, it takes 12 minutes, right? So the timeline for A will be multiple of 12. So 12, 24, 36 and so on, right? Similarly for B, I am taking a different color. For B, from for Black Shadow to go from B to A, it takes how much time? 7 by 20 into 60 minutes. I am converting into minutes. So this will be 321 minutes. So here it takes for this one to go till here 21 minutes and to come back again 42 minutes. So timeline for the B starts with 42, right? Going 21, coming back 21. So it is 42. So this will be 84 and so on. Now at what time they both A and B will reach their origins at the same time? That will be the LCM of 12 and 42. LCM of 12 and 42 will be 7 into 6 into 2, which is 84. That means 84 minutes. So exactly after 84 minutes, both of them reaches to their origins at the same time. So in 84 minutes, what you can deduce from the information is, in 84 minutes, they will meet for 9 times. Why? Because the speeds ratio is 70 and 20, that means 7:2. Since meeting they have asked, it will be 7 plus 2, 9. So 82 minutes, it will be 9 times. They have asked for 7 hours, right? In first 7 hours, how many times they meet? That's your question. 84 minutes means this can be written as 1 hour 12 minutes. 1 hour plus 24 minutes. 24 by 60, this will be 4 by 10, 2 by 5. 1, 2 by 5. This will be 7 by 5 minutes. 7 by 5 hours. So I converted this 85 minutes into hours. So in 75 by 5, 7 by 5 hours, they meet 9 times. Right? This is what you can say. Now they have asked for 7 hours. In 7 hours, how many times they meet? So in 7 hours, they meet exactly 45 times. That's it. They have asked for the meetings. So your answer for this question will be 45 times. Hope you enjoyed this video. This concept will be very much useful. Better learn the concept, because GRE is not so easy, and at the same time it's not so difficult as well. The thing is the becoming conceptual. Better you learn the concepts and face the exam. Thank you.